Hi friends, in this video I will be solving two questions, and the two trigonometric question is based on the addition formula. I could remember that I didn't solve enough question for you under addition formula, so I'll be using addition identity to solve these two questions I'm having here. And for those of you that you're having to watch my explanation and also introduction to addition formula, kindly pause this video right now and go back to watch it. Looking at this, I have been shown that cos alpha plus beta, cos alpha minus beta is equals to cos square alpha minus sine square beta. You can choose to prove from this side and you can choose to prove from this side, but I'm going to choose this side because I actually want to show you how to apply identity on this, and this is the best way to for me to prove it. Cos alpha plus beta, cos alpha minus beta. I can recall my identity for what? For cos alpha plus beta. If I have cos A plus B, is the same thing as writing what? Cos A plus B is the same thing as writing cos A cos what? Cos B. Which in this case is going to change what? Cos alpha cos what? Cos beta. Right? Cos alpha cos beta. That will be, since you're having addition sign here, this one will be what? Negative sign. Cos alpha cos beta minus what? Minus sine alpha sine beta. Similarly, if you're having cos alpha minus beta, it is still the same thing as writing what? Cos alpha cos beta. Since you're having negative sign here, this one is going to turn to what? Plus what? Sine alpha sine beta. Right? So looking at this very well, I'm having multiplication sign. An operation is here, which is multiplication operation. Then I'm going to multiply these two together. Multiplying them together on this side, I'll be having, look at this, recording this, I'm having on this my side, I'm having cos alpha cos beta, right? Minus sine alpha sine beta. Enclose it inside the bracket. Then open another bracket for this one. You're having cos alpha cos beta, right? Plus what? Plus sine alpha sine beta. Hope you see this card. Then expanding this, let's see what I'm going to have. If I choose to expand this, what is going to be the value, or what is going to be my expression? Cos alpha cos beta times cos alpha cos beta. This is going to turn towards cos, that's what? Square alpha cos square beta. Expanding this. This multiplied by this will be what? Will be plus what? Cos alpha cos beta, right? Sine alpha sine beta. Then let's go ahead again. This multiplied by this will give me what? This multiplied by this, we are going to be having it as what? Minus again, because negative sign is here. Minus what? Minus, you can choose to write as cos alpha cos beta, then sine alpha sine beta. Any way you like. Right? So looking at this again, I can also go ahead. This multiply like this, I have was minus sine square alpha, right? Sine square beta. Then this will cancel this. If this cancel this, we have it as what? As cos square alpha cos square beta minus what? Sine square alpha sine square beta. Right? But the question says you should prove that this expression, this particular expression, is equal to what? Is equal to cos square alpha minus sine square beta. And how can I prove it? I'm having cos square alpha here, sine square alpha here, sine square beta here, cos square beta here. Then what can I recall? I can go ahead and just recall from your basic identity. No, we're having cos square alpha cos square beta minus what? Sine square alpha sine square beta. That's what we have. Then I'm going to apply my basic our basic identity on this. You can recall, because since the question says show that this is equals to cos square alpha minus sine square beta, that means in the cos side I'm going to recall for what? For only the one that have beta. I can recall that my cos square beta plus sine square beta equals to what? 1. Then make this sort of formula. I'm going to have cos square beta equals to 1 minus what? Sine square beta. Right? Then if you look at this very well, you can do the same. Since you're having sine square beta here, you hold this, then you recall for this. Show that you have your sine square alpha will be equals to 1 minus what? Cos square alpha. Then go ahead and put it inside this expression. Then you have it as what? Cos square alpha into brackets. My cos square beta is what? Cos square beta. That's 1 minus what? Sine square beta. Can you see that? Then you have your negative sign here. Open another bracket. Sine square alpha. Sine square alpha is what? 1 minus what? Cos square alpha. Close the brackets. You are going to have your sine square beta outside. Then let's see what is going to happen if you open the bracket. Open the bracket, you're going to have what? Cos square alpha minus what? Cos square alpha sine square beta. Right? They have minus what? Sine square beta. And also that you should have plus what? Plus sine square beta cos square alpha. We are almost there. You are having cos square alpha on this side. Bring it out. Cos square alpha. Then agree with me. Everything here which is negative cos square alpha sine square beta is going to cancel everything here out because they are of the same. Then you have cos square alpha minus what? Sine square beta, which is what you're asked to prove. Now, let's move to the second question. You haven't proved that sine 3a equals to 3 sine a minus 4 sine cube a. The question is actually simple. Because you have to prove that this is equal to this. That means you don't need to stress yourself. Then let's go ahead and find solution to this. What's the first thing you need to do? You are having sine 3a. That's the only thing you are giving. Then how can you express this further? You can express this further by writing it as sine into brackets a plus 2a. A plus 2a, they can be added together to give us 3a, but they have the same or different function. Sine a plus 2a, that means you can say sine a plus b. Recall, you can write sine a plus 2a as something. You can write as what? As sine a cos 2a according to our addition formula. Sine a cos 2a plus what? Sine 2a cos a. That's sine a cos b plus sine b cos a. Rewriting this as this, then what do you actually need to do? If you write it as this, what other thing do you need to do? In this case, everything here will give you sine 3a, right? Which is equals to sine a cos 2a plus what? Sine 2a cos what? Cos a. Although this question is based on addition formula, and those of you that you haven't watched my addition formula, the identity I'm about to use now will be unfamiliar to you. So I will advise you to pause this video now and kindly go and watch my explanation and the formula that I proved from by using the addition formula. But for those of us that we are here, I actually told you guys that if you have an expression cos 2 theta, cos 2 theta is also the same thing as writing as 1 minus what? 2 sine square theta, right? And I told you that if you have sine 2 theta, sine 2 theta is also the same thing as writing what? 2 sine theta cos theta. Cos 2 theta can be written in let's say 3 ways. We have the one of what? Cos square theta minus what? Sine square theta. We have the one of what? 1 plus 2 cos square theta. And the one of what? 1 minus 2 sine square theta. But sine 2 theta can be written in just a single way, which is 2 sine theta cos theta. Then I will apply it here. So that I'll be having sine 3a to be equal, that will be sine a into brackets cos 2a. This is cos 2a. Then I'll have to be 1 minus what? 2 sine square a. Close the bracket. Then plus sine 2a. I will have it as what? Into bracket 2 sine a cos what? Cos a. Close the bracket. Cos a. Hope you are following me. Then let's go ahead and open the parentheses. You are going to have sine 3a equals to sine a, right, minus 2 sine cube a. This multiplied like this gives us sine cube a. Plus here, this multiplied like this. The only improvement here is this. We have it as 2 sine a cos cube a. Then looking at this, what other thing do I need to do? I don't actually need to write this since this is equals to this. So what other thing do I need to do? I can just go ahead and further simplify by using basic identity. My basic identity, you can recall that if we have cos square a plus sine square a is something as 1, which is making your cos square a sort of formula. You have cos square a to be equal, that's what? 1 minus what? Sine square a. Go ahead and fix it into this. We have sine a minus what? 2 sine cube a plus 2 sine a into brackets 1 minus what? 1 minus sine square a. Because everything here is the same as what? Cos square a. Then further simplify, you have sine a, right? Then minus 2 sine cube a plus 2 sine a. This multiplied like this will give us what? Minus 2 sine cube a. Then everything here, I will simplify it further. But before I simplify it further, I'll move it to the question. I'm asked to prove that this is equal to this. Then I've arrived to what? Sine a minus 2 sine cube a plus 2 sine a minus 2 sine cube a. Right? Then let me just go ahead and simplify. This plus this will give me what? Will give me, that's sine a plus 2 sine a minus 4 sine cube A. Then this plus this will give me what? 3 sine A minus 4 sine cube A, which is what? Proved. If you find this video helpful, kindly click on the subscription button and click on the notification button right now. Thanks for watching.